Okay, so I have here a quite interesting feature about the crystallizer equipment. Ano, so sana you can identify this. Ano? So the first one is this is the batch crystallizer. Ano? So this is the agitated batch crystallizer. Then the second one, the last one is the Oslo. This is the Oslo crystallizer. Ano, kita nyo, meron siyang, so the other name is fluidized bed crystallizer. Ito yung merong, yung output niya, yung crystals, di ba, na generally malalaki yung granules. No? So this is the Oslo. Tapos this one, the third one, this is the vacuum crystallizer. So sa vacuum crystallizer, merong merong evaporation, tapos meron ding cooling, ano? So actually ito yung isosolve natin susunod na problem, yung vacuum crystallizer. Then this one, the second one, this is the ito yung product niya, magma, ano? So this is a type of another type of evaporation crystallizer. So anyway, ito yung walang yung wala siyang crystallization bed kamukha nitong isa, di ba? Okay, check nyo na lang yung specific name nito. Anyway, let's go to the problem. So the first problem from Colson, ito yung spelling ng nung author ng libro. Sinasabi ko sa inyo, dito sila kumukuha ng board exam questions. Maraming kinukuha dito. Is about a vacuum crystallizer. So pag vacuum crystallizer, merong cooling at the same time merong evaporation. Okay? So consider the evaporative cooling of a 1,000 pound of water in a solution containing sodium chloride and potassium chloride, KCl at NaCl. Initially, the solution contains 27 grams NaCl per 100 grams of water and 34.3 grams KCl per 100 grams of water. So at 100 degrees, yun yung initial temperature niya. So applying vacuum results to boiling of solution at a lower temperature of 40 degrees Celsius. So binacuum siya, tapos nag-boil na siya. Kasi pag nag-boil yan ng mababang temperature, automatically bababa din yung temperature niya. No, ganun yung mangyayari. Kasi boiling na siya eh. Kumbaga, the evaporation will absorb the heat, and then it will result to a lower temperature kahit na mainit pa yung feed nyo. Imagine nyo ba yan? 'Di ba parang it's the same the same phenomena na halimbawa naglagay kayo ng alcohol sa balat nyo, tapos tinapat nyo yung balat nyo sa electric fan, 'di ba? Pag nag-evaporate yung alcohol, mararamdaman nyo malamig, It's definitely cooler than the air from the electric fan. Ganun yun din yung nangyayari sa sa vacuum crystallizer. Once merong evaporation, hindi ka lang nagpo-produce ng vapor per se, bumababa din yung temperature. So as you can imagine, this is very good for crystallization, kasi bumababa na yung solubility generally kasi sodium chloride, KCl, naman yan eh. Directly proportional yung solubility nila sa temperature, di ba? So, meron nabawasan nyo na yung water kasi may nag-evaporate tapos bumababa pa yung temperature. Kaya generally effective ang vacuum crystallizer. Okay, so applying vacuum results to boiling of solution at lower temperature of 40 degrees Celsius. The solution now has a concentration of 28.4 grams NaCl per 100 grams of water and 20.4 grams KCl per 100 grams of water. Calculate the amount of KCl that precipitates. Assume all NaCl remains in the solution. So basically, ang gagawin niyo lang dito, you just calculate the initial amount of both NaCl and KCl. So 1,000 pound yung water, tapos given naman yung solubility, per 100 grams of water. So basically, lang to, you just multiply this by 10, di ba? Ganun lang naman. O kaya just multiply this by 1,000, then you just divide it by 100 grams of water. Or 100 pounds of water, di ba? So you will find the initial amount of sodium chloride and potassium chloride. Na-imagine niyo ba yung sinasabi ko? So halimbawa, first you need to find out the amount of sodium chloride and potassium chloride in the solution, ano? So you can use the solubility. For example, ang sodium chloride ay 27 grams, ano? So if you have 27, let's just change the unit, ano? Let's use pounds. Kasi pounds yung water natin para mag-cancel out. You have 27 pounds of NaCl, okay, per 100 pounds of water. You might be asking, bakit pinalitan grams yung given? Bakit ginawang pounds per pounds? Kasi parehas lang naman yun. No? Yung weight ratio, bawa, ginamitan nyo siya ng conversion factor, magka-cancel out din lang yung conversion factor. Di ba? So this one, you have 27 pounds of NaCl per 100 pounds of water. And then, you have 1,000 pounds of water. So just multiply this by 1,000 pounds of water. So ito nga sinasabi ko sa inyo, magka-cancel out lamang yan. No? Dalawa. So basically parang yung mga zero, parang minultiply nyo lang ng 2. Tapos yung pounds of water, magka-cancel out din. So you will have, you can find out that the amount of NaCl is around 270 pounds, no, of NaCl. So the same thing with KCl, di ba? You just multiply the solubility by 10. So if you have 34.3 grams of KCl, so therefore you have 343 pounds of KCl. Nakuha ba yan? Do you have any question? Minultiply ko lang ng 10, ano? Kasi, di ba, 1,000 divided by 100 is 10. Anyway, let's proceed. So, if you apply vacuum, it will result to cooling and to evaporation, ano? So, ang key dito, ito, assume all NaCl remains in the solution. So, gagamitin natin yung amount ng NaCl to find out kung gaano kadami yung water na natira. Kasi we have the solubility of NaCl. The solubility of NaCl at the new temperature at 40 is 28.4 grams of NaCl. So gagamitin natin yan. Itong 270 at saka itong solubility to find the amount of water. So, halimbawa, we have 270 pounds of NaCl. Tapos you just simply divide this by 28.4 pounds of NaCl. Ito yung bago niya solubility. This is the amount dissolved per 100 pounds of water. Can you follow the logic? So magka-cancel out ito. So pag kinumpit nyo, $950.7 or 951, di ba? Yung water. So ito na yung ito na yung water after evaporation. From 1,000 pounds naging 951 na lang. So basically ang gagawin niyo na lang is find out kung how many pounds of KCl is still dissolved in water using this solubility 20.4. No? So halimbawa, you have 951 pounds of water. Okay? And then 20.4 pounds of KCl still dissolved in water per 100 pounds. Ay, baliktad pala. Sorry, baliktad. Nakikita niyo naman agad, Makikita niyo naman kung mali yung conversion niya. Dapat nasa ilalim yung pounds of water. So, multiply lang natin ito ng 20.4 pounds KCl. Tapos, 100 pounds of water. Per 100 pounds of water. So, magka-cancel out ito. Diba? And then, you will have the amount of KCl. Still in the solution. No? So, i-minus nyo lang yan doon sa original na 343. You will have the final answer. So, I have 194. Kuha niya, 194. So So you have 194 pounds of KCl still dissolved in water. So i-minus nyo lang doon sa 343. So 343 pounds of KCl, yung original, minus 194 nasa water pa. So you're going to get this one. Yung sorry, yung 149, di ba? Yung 149. You're going to get the 149 pounds. Do you have any question regarding this problem? Talino naman. Do you understand the solution? Okay lang ba? Medyo hindi nga lang talaga si standard. Itong ganito yung mga problem pag vacuum crystallization. Ganun yung technique, ano? Isa-isahin nyo. Okay, so if you don't have any question, let's proceed to the next problem. Okay, so this one is example 15.5. Still from Colson, ano? Still from Colson. So ito, in this particular problem, we're going to calculate the length of the Swenson-Walker crystallizer. Kung natatandaan niyo pa, a Swenson-Walker crystallizer is a type of cooling crystallizer, no? Kasama siya nung batch. So you just simply cool the solution tapos walang evaporation, no? So tapos fix yung kanyang diameter 0.6 meter, di ba? Pero continuous siya. Okay, so ang kina-calculate lang dito yung length. So, ang rule of thumb in calculating Swenson-Walker crystallizer is for every 1 meter squared, no? So assume, dugan natin assume for every 1 meter squared ng area, no? Area ng Swenson-Walker crystallizer. This is equivalent to 1 meter length. No? This is 1 meter squared na area. So this is equivalent to 1 meter length. Okay, so let's read the problem. A solution containing 23% by mass of sodium phosphate is cooled from 313 to 298 Kelvin in a Swenson-Walker crystallizer to form crystals of sodium phosphate. What is 12? Dodeca, That's dodeca. Dodecahydrate. Okay? Tandaan niyo pa? Tandaan niyo pa ang organic niyo. So the solubility of sodium phosphate at 298 Kelvin is 15.5 kg per 100 kg of water. And the required product rate of crystal is 0.063 kg per second. So medyo iba yung problem. C yung given. Generally, F yung given. This time, C yung given. So the mean heat capacity of the solution is 3.2 kilojoules per kilogram per degrees Kelvin. And the heat of crystallization is 146 kilojoules per kilogram. If cooling water enters and leaves at 288 and 293 Kelvin, so meron tayo, siyempre, paano ba lalamig yung solution? So generally, gumagamit ng water. So at 288 to 73, this is mga 15 degrees Celsius yung tubig, Tapos paglabas niya, 293 is 25, di ba? Ganun. Para ma-imagine nyo, Pag walang given na regarding the flow arrangement, so i-assume nyo na lang na yan, counter current, Counter current yung ating flow arrangement. Tapos, you're still going to, kasi parang heat exchanger din lang naman yan. So, gagamit pa rin kayo ng design equation ng heat exchanger. Yung Q is equals to U times delta T LMTD. Tandaan nyo pa yan? Q is equals to U, overall heat transfer coefficient, and may given ng overall heat transfer coefficient 140 watt per meter squared per degrees Kelvin. Q, tandaan nyo pa to? Q is equals to U times A times delta T LMTD. So basically, ang gagawin natin, we're going to calculate Q. Tandaan niyo pa naman yung mga problem natin, di ba? We're able to calculate Q. This is just FCP delta T plus C lambda C. So pag na-calculate nyo na yung Q, given naman yung U, and then calculate na rin yung delta T, L, and TD. Remember, meron tayong temperature ng water, no? Tsaka meron tayong temperature ng... Meron tayong temperature ng water, at saka meron din tayong temperature ng solution. Ano? So, imagine niyo na lang counter current yan. So makakalculate niyo yung area. So once na na-calculate niyo yung area, kung ilang meters squared yung na-calculate niyo, yun na rin yung magiging length niya. Kasi ito yung rule of thumb. For every 1 meter squared ng Swenson Walker na na-calculate na area, that is equivalent to 1 meter length. Okay? So I guess para medyo mas orderly kasi medyo mahaba yung solution. Mag-ano na lang tayo, mag-whiteboard tayo. Kita niyo naman yung answer. We're supposed to arrive at this answer, 9.22 meter. So first, I'm going to write the given, para makapag-mass balance tayo. So consider a crystallizer. Meron tayong feed, no? So the feed contains sodium phosphate, We have sodium phosphate. So this is actually 23%, 23% sodium phosphate. Okay, tapos the solubility at this temperature is 15.5 per 100 kilogram. 15.5 kilogram sodium phosphate per 100 kilogram. Tapos ang ating crystal ay dodeca, dodecahydrate, sodium phosphate 12H2O. Okay, tapos may given tayong C. C is equals to 0.063 kilogram per second. Okay, so as you can see, dalawa yung unknown natin, F at saka L. So kailangan natin hanapin yung F kasi di ba ang Q natin ay FCP delta T plus C lambda C. So kailangan natin hanapin yung F para ma-solve natin yung problem. So since this is just a Swenson Walker, pag Swenson Walker, ang BI equal to 0. Bakit equal to 0 ang B? Kasi ang Swenson Walker ay cooling crystallizer. So wala siyang evaporation. No? Question regarding that? So pag nag-overall mass balance tayo, F is equals to L plus C lang. Tapos alam natin yung C. Halimbawa, ang basis natin is 1 second of operation. Okay? So we have F is equals to L plus 0.063 kilogram. Question regarding overall mass balance. Tapos sunod, syempre mag-ano tayo, sodium phosphate balance. Nakita nyo hindi palaging F yung given, pwedeng L, pwedeng C, pero just proceed. Just proceed like just do the overall mass balance and then just do the sodium phosphate. As long as dalawa lamang yung unknown, you can solve the two unknowns, Kahit ano pa yung given. So sodium phosphate balance is just F times 0.23. Tapos L, alam niyo na naman to, multiply niyo ng 15.5. Tapos divided by 115.5. Alam niyo na naman yung reason behind that, Tapos yung C, kailangan niyo siyang i-divide ng molar mass ng sodium phosphate called H2O. So ang molar mass nito ay, kayo na lang mag-confirm. So ang molar mass ng sodium phosphate ay 380. This is 380. Tapos yung sodium phosphate, ito lang, ay 164. Okay, so i-multiply nyo ito ng 164 divided by 380. Do you have any question at this point? So meron na kayong this one is 0.63. Ano? This one is 0.6063. So, yun, you can now solve F. F yung kailangan natin. Gagamitin natin yung F dun sa equation ng Q. So, ang Q natin ay FCP delta T plus C lambda C. Okay? So, kaya kailangan natin yung F. So, just get your calculator, try to find F. Practicein nyo kasi medyo iba siya sa ginagawa natin before. F yung given. So, ang experience ko nung midterm nyo, pag medyo iniba na yung given, hindi na kayo makasolve. Ano? Dapat kahit ano pang gawin, tulad ng isang problem sa evaporation, yung 15 points. Pero naman nakakuha. Meron mga nakakuha. Sina Gio ata nakuha nila. Tandaan niyo yun, yung 3 equation 3 unknown sa evaporation problem. Pero ang daming mali. So, anyway, you just try to input this in your calculator. No? So, halimbawa, F is 1, tapos transpose nyo yung L, magiging negative 1, di ba? Negative 1 yung L. Tapos 0.063. Madali lang naman yung first equation. Yung second equation is 0.23, tapos negative, kasi lilipat niyo yung L sa kabilang side, 15.5 divided by 115.5. Okay? Tapos finally, you have 0.063 times 164 divided by 380. So, anong F? Anong value ng F? Anyone? Ano nakuha yung value ng F? 0. Yes, very good dyan, Paolo. 0.196. Very good, Gio. Ano? So I hope the other people are able to get the value of F. Ano? 0.196. So this is in kilogram. Ano? Yun. Tapos, try to solve for Q using this equation. Tandaan niyo pa to? FCP delta T plus C lambda C. So Q, yung F is 0.196. Okay? This is actually kilogram per second, ano? Tapos ang given na CP sa problem ay 3.2. Multiply niyo ito ng CPF, 3.2 kilojoules per kilogram Kelvin. Tapos yung delta T, di ba? Pinalamig natin from 313 hanggang 298. Tama? So yun yung given sa problem. Ano? Tapos i-add natin yung sa yung sa crystallization. So ano nga ba to? Sodium phosphate. Sodium phosphate is a regular guy. So ibig sabihin pag nag-crystallize siya, para mag-crystallize siya, you need to remove some heat, ano? So ang ating C ay 0.63. Ayun, given, no? 0.063 kilogram per second. Tapos ang lambda C niya ay 146.5. So diretso lang to, ano? Kasi yung 146.5 ang unit niya ay kilojoules per kilogram. Yun naman yung maganda sa problem. Sa kay Colson, hindi na kayo pinapahirapan sa conversion. Diretso lang, wala nang conversion, di ba? Okay, so just solve this. Solve nyo lang to for Q. So 0.196 times 3.2 times 313 minus 298. Ako, I made it a point na nagka-calculate ako kahit na may sagot na ako dito. Pumipindot pa rin ako sa calculator para, siyempre, para ma-check ko kung tama yung sinulat ko sa inyo. At the same time, para hindi masyadong mabilis yung discussion, ano? Para ma-absorb nyo muna. So, kaya kuha kayo ng calculator. No? So, I'm getting something like 18.64. Did I also get 18.64? Okay, very good, Kissy May, very good John Paolo. 18.64, ano? So, ang unit nito ay kilojoules per second. This is what? Kilowatts, this is kilowatts, ano? So, ito na yung Q na gagamitin natin doon sa Q is equals to U times delta T LMTD, ano? So, calculate muna natin yung delta T LMTD. So, halimbawa, ito yung Swenson Walker. So, given na yung pumapasok ay 313. Yung feed, ano? Yung feed, 313 yung temperature niya. Tapos paglabas niya, 298. So, pinapalamig siya ng water. Ito yung water. Yung water naman, pagpasok, 288. No? 288 yung temperature ng water. Tapos paglabas niya, it would be 293. Marunong pa kayo mag-calculate ng delta T LMTD. So this is 10. Diba? That's delta T2. Tapos delta T1 is 20. Diba? So mga approximately, dapat na makuha nyo mga around 15. Diba? So let's calculate delta T LMTD. So diba, ano lang naman to? Delta T2 o delta T1 minus delta T2. Mas malaki kasi yung delta T1. ln delta T1 divided by delta T2. Ito yung delta T1. Ito yung delta T2. Tandaan nyo pa? Yung kakalimutan yung mga previous lesson, ha? Anyway, this is just 20 minus 10 divided by ln 20 divided by 10. Ano? So pag kinalculator niyan, you're going to get something like 10 divided by ln of 2. Ano? 14.42. Yes, so delta T LMTD is 14.42. Okay. Okay, very good, Paolo. 43 pala, 43. 14.43. Okay, so let's go to the next page. So gagamitin natin yung equation na Q is equals to U times A times delta T LMTD. Okay, so this one we have 18.46, ano? 18.64. Sorry. Dali lang. 18.64, not 18.46. So 18.64. Okay, ito yung formula natin, ano? UA times delta T LMTD. So basically, hanapin lang natin yung A. A would be the answer. Kasi 1 meter squared is equals to 1 meter length, ano? So this is in kilojoules per second. Tapos, ang U is 140. Yung given na U is 140 watts per meter squared per Kelvin. No? So kailangan maging watts ito. Kilowatts kasi siya. So multiply nyo lamang ng 1,000. Ano? So yung 1,000 is to convert kilowatts to watts. Nawala nyo. Question? So it was A. Tapos yung delta T LMTD natin is 14.43 Kelvin. So magka-cancel to. So yung A natin is in meter squared. Pindot ulit sa calculator, 18.64 times 1,000. Tapos divided by 140 is divided by 14.43. We're going to get something like 9.22, 9.23, ano? Probably rounding off. Okay, tapos sabi, di ba, na-assume natin na for every meter squared ng area, that would be equal to ano? That would be equal to 1 meter lang. So therefore, di ba, tandaan nyo yun, sinabi ko sa inyo, assume that for every 1 meter squared of area, this is equivalent to 1 meter length ng Swenson Walker. No? Okay, so therefore, the length is approximately equal to 9.23 meters. Question? Do you have any question regarding this problem? So basically, ganun pa rin naman, nadagdag lang to, Nadagdag lang to, and then you need to calculate the delta T, L, and T. Do you have any concern? Do you have any question? Do you think you can solve this type of problem from the old board exam? Oo, sige, Jericho. Sandali lang. Okay, so if you don't have any question, we have only 3 minutes on this on this session of Zoom. So I want you to solve the next problem. This is from MRII. Okay, so this is from the MRII reviewer. A Swenson Walker crystallizer is used to produce 1 ton per hour of copperas. So yung copperas and yung ferrous sulfate, heptahydrate. So tingnan niyo na lang sa PowerPoint. Crystals by cooling a saturated solution at 120 degrees Fahrenheit to 80 degrees Fahrenheit. Pag sinabing 1 ton, ano yan ha? 2,000 pounds. Ha? Iba yung metric ton sa ton. Ang ton 2,000 pounds, ang metric ton 1,000 kilograms. So a matter of 200 pounds. Malaki yon. So by cooling a saturated solution at 120 degrees Fahrenheit to 80 degrees Fahrenheit cooling water. Cooling water entered the cooling jacket at 60 degrees Fahrenheit and exits at 70 degrees Fahrenheit. U for crystallization is 35 BTU per hour per foot squared per degrees Fahrenheit. So English tayo ha, English. So solve this using English unit. Heat of solution is 4,400 calories per mole. Screenshot kasi mawawala na yung ating Zoom in 2 minutes. So heat of U for crystallization is 35 BTU per hour per feet squared per degrees Fahrenheit. Heat of solution is 4,400 calories per mole. Yun. Takot-takot na conversion to. CPF is 0.70 BTU per pound per degrees Fahrenheit. Kaya meron nang hindi pumupunta ng third day eh. Pag nahilo na sila sa mga conversion ng second day, grabe magpa-convert. Solubility at 120 degrees Fahrenheit is 140 kilogram copperas per 100 kilogram water. Pakibago to. Ito? Ano lang to? Ferrosulfate lang to. I think ferrosulfate lang to. Itong 140 kilogram copperas. So ang copperas kasi heptahydrate yan, So gawin niyo lang tong ferrosulfate. Pero ito yung solubility niya kasi 'di ba if you still remember sa handbook, ano lang yan, formula weight, So ferrosulfate lang yan. Solubility at 80 degrees Fahrenheit is 74 kilogram ferrosulfate per 100 kilogram water. Calculate the crystallizer area. Actually, sa original MRIs, if you have the MRI, multiple choice. So anyway, I want you to calculate sige, gagawin ko multiple choice sa BBL, Pero screenshot niyo lang muna to. Para maka-start kayo mag-solve. Nawawala na siya in a little. Tama na? Nakuha niyo na? Screenshot niyo na? Okay. So lipat na lang tayo ng kabilang kabilang Zoom. I will share the Zoom again.